video presentation on the magnetic limit switch, which I've been researching over the past week. What is it? The magnetic limit switch is a limit switch that is activated by detecting a magnetic field instead of a movement, like a normal limit switch. A normal limit switch is much more similar to a switch that you can find in a house. Limit switches are useful because they allow you to know the limits of a mechanical construct, hence the name, limit switch. For example, the range a 3D printer extruder can move can be calculated with the limit switch. This is useful because although you can hard-code values into the software, limit switches let you calibrate the machine much easier, especially if the hard-coded values in software aren't accurate, because machines like 3D printers tend to move over time. This is what it looks like. This is the sensor itself, and these are two magnets that come with it. There are little magnets here that are able to attach to the magnet inside the magnetic limit switch, activating the machine. And this is a wire that's used to connect to the rev control hub. How is it coded? The magnetic limit switch has to be declared as a rev touch sensor in the hardware map and calibrated as one. This is because the magnetic limit switch acts similar to how a normal limit switch would, which is essentially a touch sensor. There's a default method in the magnetic limit switch called isPressed. This returns true if the limit switch detects a magnetic field and false if it doesn't. To initialize a magnetic limit switch in the hardware class, you type in public rev touch sensor limit switch equals map.get rev touch sensor.class limit switch. Additionally, to get feedback from the sensor in an autonomous or TeleOp, we need to make a method to return the default isPressed method to the hardware class, from the hardware class, and then call it in the class of our choice. To do this, we need to make a method called isPressed, which just returns limitswitch.isPressed. Now we can use it in any op mode we want as long as we initialize the map object from the hardware class. Here's an example of a teleop where the telemetry for the magnetic limit switch is displayed. In this example, the limit switch would return a true value and print true in the telemetry when the magnetic limit switch is activated. The reason magnetic limit switches are useful is because we can precisely control the maximum or minimum distance we want slides to move. For example, if we put a magnet and the sensor on a set of slides in such a way that the exact distance we want the slides to move is when the magnet and the limit switch go past each other, we can program the servo or motor to stop running as soon as the switch is activated. If the slides are configured properly and with some proper coding, this could be really useful to set exact lengths for slides to move. An example of this might be if the limit switch is activated, we stop the robot. To configure the magnetic limit switch, it needs to be plugged into one of the digital ports on the controller expansion hub, not I2C like most other sensors. In the configuration settings of the driver station, the port plugged in has to be configured as a rev touch sensor, just like how the code is configured. Some extra information about the magnetic limit switch. The range for the limit switch is only about 1 centimeter, but I found that contact is the best way to have the sensor read a magnetic field. The sensor itself is magnetic, so it attracts other magnets towards it, so this is a way that contact is made easier. If the limit switch is configured correctly, a blue light is visible from the top of the limit switch when it detects the presence of a magnetic field. And also, a quick disclaimer to not drop any magnets into the robot, since there are many magnetic parts like motors that are inside of the robot, and having a magnet drop into the robot might make it difficult to find it again, or might have it fall out during competition.